Welcome to solverfy.
In the given problem, we have an electron that exists in a rectangular two-dimensional well. So let us draw the well. So imagine this is a two-dimensional plane where we call this as x-axis and this as y-axis. The length along the x direction is equal to L, while along the y direction is equal to 2L. We know that the energy of an electron is given as h square nx square plus ny square 8m divided by over lx square. So lx square in this case is L, so I can simply write as L square, and here ny square, which is 4 times L square. So now we can express this in terms of, because we require what multiple of h square over 8ml square. So let us first express the whole result in terms of 8 h square over 8ml square. This can be now be written as nx square plus ny square over 4. So this is the energy of an electron in state nx along x direction and ny along y direction. So our first problem is to find out what is the energy of the electron in the ground state. The ground state in this case will be nx equal to, this is A, so we'll have nx equal to 1 and ny equal to 1. This is our state. So the energy of 1 comma 1 in this case we need to find out the multiple, so which is this number. So the question is, what multiple of h square over 8ml square gives the ground state energy? So this will be equal to h square over 8ml square into 1 plus 1 over 4. So we see that this multiple is 1.25. Next we go to the, let's go to the next one. So in B, we need to find out the energy of the first excited state. So as you can see that the energy in the nx and ny is given by this relation. The next excited state would correspond to ny equal to 2 and nx equal to 1. So we have nx equal to 1 and ny equal to 2, and the ratio in this case, so what is our ratio? The ratio is given just by this number because this is h square over 8ml square factor. So this is going to be 1 plus 2 square over 4, which is 1 plus 2 square is 4 over 4, and that's equal to 2. Now we go to the next one. The next one is the energy of its lowest degenerate states. A degenerate state is one where two states have the same energy, two or more states have the same energy. So we'll have to look for states that have the same energy, or states with value of nx and ny, different value of nx and ny, which have the same energy enx, eny. So the combination in this case, the lowest sets comes out as 1 comma 4 and 2 comma 2, and you can check for yourself. We'll check for one of these. So let's try this one. 1 plus 4 square is 16 over 4, that gives us 5. Similarly on this side you can say this is 2 square, which is 4, plus again a 2 square, which is 4, so 4 over 4. So you see 4 plus 1 is again 5. So these are the two states that have the same energies. So we say this is two-fold degeneracy. Okay. And then for the last one, in this case, we need to find out the difference between energies of second and third excited state. The first excited state was this. The second excited state would be 1 comma 3. This is our second excited state. And the third excited state in this case corresponds to 2 comma 1. So you can check these values for yourself that there is no other combination between 1 comma 3 and 2 comma 1 which has an energy lower. So this is a third. And the difference in energy would be, we'll make this combination first, which is 1 plus 9 over 4 because it is 3 square, and then 2 square is 4 plus 1 over 4. This is 4.25 and this is 3.25. So the difference between the two is simply 1. So because we require the energy, the multiple is just 1, because what we need is in terms of the multiple of h square over 8 ml square.